Hello everyone and welcome in today's tutorial where we're going to be learning about polymorphism. Polymorphism allows you to use the same function and have different outcomes. For example, we have a class called enemy and we are making a video game. And we have, for example, two enemies. One is a ninja, one is a monster. So what will the ninja and monster do? What do they have in common? They have a attack power, but the attack power is not the same. So, for example, let's in our protected access modifier, we learned about the protected access modifier in last tutorial. I hope that you watched it. So let's put attack power. And now let's make a public access modifier, and that will be called set attack power. And we're going to pass a variable called a that will be a symbol of attack. So attack power is equal to a. Perfect. So like I said, we will have two other enemies that are ninja and monster. So let's make a class called ninja, and we will inherit the stuff in the public access modifier from enemy. And what we're going to do, let's make it public. So void a tag, we're going to make a tag function, and inside of here, we're going to console out um, samurai ninja. And here, like in video games, like the old video games, we are going to put the attack power. That's how it's set. But we had like lines, and ninja did that much attack power. Perfect. So what we can do, I don't recommend I said it. We just copy this, paste it. Oop. Yeah, perfect. So what we actually do here is we just simply change from ninja to monster, simply like that. So now when we go back to the main function, let me first code this, or wait, I will just copy and paste this because I am ready for this tutorial. So this is a bit complicated, to be honest. So I want to explain it to you in a better way. Here we have a object for ninja and monster, but we call them by the enemy class. We are creating a pointer object for the enemy class, and we're setting it equal to the location or the memory address from ninja and monster. We're doing this because ninja is of type enemy, so this is valid. And anything that an enemy can do, a monster can do, because it inherits this from the enemy. So when we do this here, ninja is just a more specific type of enemy, and every enemy has an attack power. So as you see here, we have an attack power, and that's why we can use it by both enemies. But we can't use enemy 1 because it's type enemy, and enemy class does not have a attack. And uh, we don't need to return 0. It's just a old type of syntax, but in modern C++, it gives you an option whether you want or not, so I don't want this to confuse you. And what virtual members make this even easier. So what I want you to understand here, I know this is confusing, but we need to, as you see here, we made a pointer object and we set it equal to the memory address of ninja in the memory address of monster. What we did there is we used the enemies to point to the attack power. So we are setting their attack power. And we are telling them to attack because uh, can't use enemy 1 because it's type enemy and enemy class does not have attack. Let me just pull up Paint because I know it may be confusing. So let's say we have enemy and monster and ninja inherit the set attack and what was it again? The attack power and set attack power. What does that mean? So both enemies have in common are the set attack. I cannot write it whole, but this is the set attack and the attack power. So power. Both of them have that. I know my writing is catastrophic, but that's what I can do with a mouse. So both of them have that in common. Let me just simply write it with text so you can understand better. So we have set attack power and attack power. Can we make it better, bigger? Yes, like that. Perfect. So this comes directly from the enemy that they inherit. So they get the set attack power and attack power. But as we know, the monster cannot have the same attack damage as the ninja. So for example, our monster, it has, for example, 99 attack damage and the ninja 26. But we set it up in the monster class and in the ninja class, so they are separate. And what we do is simply, when we go back here, we call the enemy class and we make a pointer object, and it points to the memory location of the ninja and the monster. And what exactly it points is the attack power, the set attack power. It points because we want to get the value we entered, and we want to get the memory location. So when we use the object that's pointing to the memory location, we can check the attack. For example, here we see that it used the attack power, and we can set the attack power back in the enemy class. So it can say, when we call it back, it can say, okay, so what we did here with the object pointing to our ninja and monster object, it checked out that we use it in our void attack function that's only available in the monster and ninja class, and we are setting them the we're setting the attack power equal to 29 and 99, and we cannot call them because the attack power is in the monster and the ninja class. So here we are setting them. We are setting them up. And the only way we can set them is if we create a object that points to their memory address. And here we are calling them with their own object because the enemy class does not have the attack object. I mean, the attack function. So that's why we're calling it. But it shows us, let's run this. It shows us the value of it because we set it equal through its memory address. And you know, if we set it equal to its memory address, like we pass with reference and with value, when we go directly to its memory address, we change it. The new data overwrites the old data. But in this situation, we don't have any data, so we are just updating it.